Okay, YouTube, in this video we're going to discuss how to add and subtract complex numbers in standard form. Okay, so recall that a complex number in standard form is any number where we can list a real number plus an imaginary number. It all comes out to be some complex number in standard form. What we're concerned with doing in this video is maybe taking two complex numbers that are different, a plus bi, plus c plus di. The cool thing about this is when we do addition and subtraction of complex numbers in standard form, we can just drop these parentheses here because we've got a positive in front of this. Ooh, I don't want to confuse that with the plus or minus. A positive in front of this set of parentheses here. Basically what it comes out to be is this right here. And it's going to be combined like terms. So just combine like terms, okay? So I is certainly not a variable. However, we're going to treat it like one. So if I were to add these two numbers together, I would just add the a and the c part together, and then the bi and the di part. So what I would get is some new number. We say a plus c, whatever that is. This is going to be my new real part on my new complex number. Plus now, if I added bi plus di, well, I'd have to add the b and the d part together, b plus d, and then I would just put the I off to the side. But this would be my new imaginary part. Okay, so it's my new imaginary part on my sum. So that being said, this is kind of the same thing I've listed up here in these rules. So we say the sum of complex numbers, if you were to add a plus bi to the number c plus di, what we'll do is we'll just add the real parts together. The real part plus the real part gives us the new real part of my new complex number. And if I were to add the imaginary part to the imaginary part, I would get the new imaginary part on my new complex number here. Okay, so the same thing applies here when you do subtraction. We got a subtraction here, a difference. The important thing to recognize though is when you're doing subtraction, you end up with a situation where you're saying, well, I've got a number a plus bi, this is my number, and I'm taking away the number c plus di. The thing is, when you look up here, I say, well, in this case, I'd get, well, then a minus c would be my new real part, and I'd get b minus d, and then I would be my new imaginary part. But what we're really doing is you could look at this as having a negative 1 in front. And what we're doing is distributing it. So we get a plus bi. Negative 1 times a positive c is negative c, and a negative 1 times a positive di is negative di. So when we add these together, I would get now a minus c, that was my new real part, plus now b minus d, that amount of i's. Okay, so this would be my new complex number in standard form, where this is my real part, and this is my imaginary part. Cool? Alright, so let's try a few. I just want to add or subtract these numbers down here. So it looks like we have a complex number plus a complex number. If it's ever addition, we can just go ahead and drop the parentheses. So we've got 4 minus I plus 3 plus 2i. In this case, we want to go ahead and start by just combining the real parts. So we'd say, well, my new complex number would have a real part that combines the 4 and the 3. So 4 and 3, they combine like terms out to be 7. And then we say, okay, now that I've combined those, we say a negative I and a positive 2i. Well, this is a negative 1i and a positive 2i. So negative 1 plus positive 2 is 1. And then we get I. So we'd say, well, this comes out to be plus just a single I. So adding these two numbers together, really, I gotta tell you, it's just combining like terms. It's simplifying. So on letter B here, when I say let's take these two complex numbers and subtract them, the first thing we need to do is we need to distribute, okay, this negative here. So we get this, we get 7 minus 5i from the first set of parentheses there, minus 5i. Then we say negative times 1 is negative 1, and a negative times a negative 5i, okay, we get positive 5i. So now combining like terms as we did previously, we say the real part here plus the real part here gives us the new real part. 7 minus 1 is 6. We say the imaginary part here plus the imaginary part here. Those things cancel out. So I can write this as 6 plus 0i, or I can write this as 6. And one thing I want to mention is we got a purely real answer. There's nothing special about this. It's just that we did. I wanted to point it out. Purely real. Cool. All right. So now the last thing we're going to do is we're going to add three complex numbers. Actually, subtract and add. We're saying 6, which is a complex number. Just to bring this up, this is the same as 6 plus no imaginaries. We're taking that complex number and we're subtracting off this complex number here, and then we're going to add this on. So we're going to do this from left to right. So first things first, let's simplify. We've got a negative in front of this set of parentheses here. Let's go ahead and distribute it. So we get 6. Now a negative 1 times a negative 2 is a positive 2. A negative 1 times a positive 9i is negative 9i. And since this number here, this complex number, this set of parentheses has a positive in front of it, we're just going to go ahead and leave what was on the inside alone. It was fine. So now all we're responsible for doing is combining like terms. I notice we need to add up all the real parts here. So the real parts, they add up 6 plus 2 is 8. 8 minus 8, so we get 0. And I'm actually going to write 0 here. So now let's go back through and let's add up the imaginary parts. So we'd say a negative 9i and a positive 4i is a grand total of negative 5 of those I things. So we can write it like this, which would be a complex number in standard form, where we could clearly see the real part and clearly see the imaginary part. Or we could rewrite this as just negative 5i, which I do want to point out, not that it's special or anything, is purely imaginary, which is cool. Okay, so this is the rundown on how you add and subtract complex numbers. You just combine like terms. Cheers.